Alright, so we want to be able to simplify algebraic expressions that have fractions like these, also called partial fractions. The way we do this isn't too complicated. The method I'm going to show you is slow but reliable. No matter what you get, you can always solve it if you do it this way. First thing we're going to do for this is we're going to make it such that the denominator is the same across each fraction. To do this, first thing I do is I box it up. So I go box, 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 box. Next thing I'm going to do is I'm going to go to a new line and I'm going to say 3 over x plus 5. I'll leave a space, I'll put in the plus, and I'll go x, take 2 under 4. Now, notice how I've boxed everything up. Or bracketed it up. What I'm now going to do is I'm going to look at the first denominator and then the second denominator. Because they're different, I'm going to go times, and I'm going to multiply the bottom by the second denominator, and then I'm going to multiply the top numerator by the second denominator. Looks like I'm changing its value, but all I'm really doing is changing its appearance. Next step, I'm going to look at my second denominator, compare it to my first denominator. I'm like, they're different, so I'll multiply. So it's x plus 5 multiplied both upstairs and downstairs. Again, looks different, but same value. Just a cosmetic change. The consequence of this operation here is both fractions now have a common denominator. And when they have a common denominator, it allows me to combine them together. So I'm going to get 3 times x take 2 plus 4 times x plus 5. We cool with that so far? All right. Next step, we can expand the brackets and then simplify. I'm going to leave the bottom in its factorized form though, and it will make sense why after. Collecting the like terms upstairs. And therefore, we're able to express our partial fractions as a single fraction. Does that make sense?
Is that what you're leaving out at, or is would it get simpler?
You can. I was just looking at it.
Yeah.
If we simplify it, we could get x plus 2. That's probably better even. The reason why this is probably better is if there was factors upstairs and downstairs, you can cancel out.
Yeah.
But typically you don't want it like that. But does that make sense? So first step, identify your denominators, bracket everything up. Second step, make it so that the denominators are the same. You do this by, first fraction is multiplied up and down by the second denominator, and similarly, second fraction's denominator is multiplied both upstairs and downstairs by the first denominator, and this gives you a common denominator. After that, you expand that, collect like terms, and simplify where possible. Note, we don't expand the downstairs because it doesn't give us any benefits. You can expand later if you need to. Is that cool? Mm-hmm. All right, did we get that down? Do you want me to show you the solving the equations one now?
Yes, please.
All right. When you're ready, I'll wipe it out.
Yeah,
Ready?
yeah.
What questions do you want us to do all of them?
Yeah, you'll do every single one in that doco.
There's not that many.
Oops.
No.
Okay, solve for the unknown. Nick, favorite number?
7.
7 over x plus 2. Take
It's
3
actually 27.
over
Oh, okay.
x plus 1 equals
27.
2 over, we'll just save it as 2. Seem cool?
Yep.
Okay, same process. What we're going to do is we're going to solve for x. The way in which we're going to do this is firstly, we're going to bracket everything up. Next step, go to the new line. We make the fractions have common denominators. This is done by firstly, write your fractions out, then multiply them. Multiply them by the other denominator. Gonna have to move that. It's a shame. All right. Now to this step, we have to stop because we could run into a problem here. Notice we have a negative here. Negatives and fractions are not nice sometimes because they get in the way. What we can do is we can just change it to a plus. But if we change it to a plus, there has to be a consequence. If that becomes plus, up there, everything's sign gets flipped around. So it's -3 upstairs now. Next step, we carry out the multiplication. It becomes downstairs, x plus 2, x plus 1. And then you get something big upstairs. That should be equals 2. Bringing these together, 7x plus 1 plus -3, x plus 2. It's still 2 on the right here. Working down the page, we're going to get 7 x's plus 7. Take 3 x's, take 6. And that's all equal to 2. Underneath that, we're going to get x plus 2, x plus 1. Now, it's at this point, it looks like it gets really messy. We don't like messy stuff. What we can do is, normally we would collect like terms here, but we're going to do 2 steps in one. Firstly, we're going to collect like terms, and then secondly, we're going to get rid of the denominator here. Any ideas how we get rid of this denominator?
Multiply the other side.
My man, that's why you get paid the big bucks.
Oh, do you get paid them?
Apparently.
Lollipops.
Oh, that's all I need.
Sustenance.
Now sometimes when it's all equal to 0, life is good. But today, life is a little bit harder. That's just life. Okay, 7x take 3x is 4x's. 7 take that is 1. So this is going to be 2x plus 2, x plus 1. Then it turns into something we can solve. We get a quadratic. Expanding out the right-hand side is going to be 2x squared plus 3x plus 2. And then that's going to become 2x squared plus 6x plus 4. It's still 4x plus 1 here. Working our way down, make one side equal to 0. So we can just say 0 equals 2x squared plus 2x plus 5.
Right.
Is that right?
3
Plus 3.
wouldn't it
Mm-hmm. Just checking. All right, and then how do we solve this?
be? Quadratic formula. Calculator.
Sum product maybe?
Calculator.
Using calc. Seem cool? So you say up, we come to our calc.
Do you want me to get the graphics calculators?
I'll grab them in a sec. Up we come to the calculator.
Is this document all we're doing today? The
Yep.
partial fraction?
Yep, all of it.
Better get it done then, or else
That's already finished.
it's already finished.
In my
That's not good enough.
That's pretty good. All right, so run matrix mode. You guys remember this from the other courses?
Yeah.
So it's options, calc, solve n, and then you just type it in. So 0 equals 2x squared plus 2x plus 3. We're solving for x. And this one's going to give us no solutions, they're complex.
Can't you just go on the equation instead of run matrix and
Yeah, no real solutions. Yeah, there you go. No real solutions. Any questions? Seem like something we can do?
Yeah.
So this method, it is slow, but it's reliable. It never fails you. For our course, for methods, you can write no real solutions. For spec, you'll just calculate the complex solutions, but you shouldn't see complex solutions until we get up to complex numbers. We all good?
Yep.
Legendary.